Hello, welcome, namaskar, sat shri akal, marhaba, hola, bonjour to all my lovely warriors and welcome to JEE Enlite, the dedicated English medium channel for all the JEE and NEET aspirants. And today's session, well, like you can see out here, it's all about your Newton's laws, circular motion and friction. Very much related chapters, and this is a one-shot session where I'm going to give you the mind map. I'm going to teach you all the important concepts and revise through the formulas, revise through the theory. And this session is for all the 12th as well as the dropper students. Well, if you're an 11th student, you can still watch it, but keep in mind that this is going to be more of a revision. Hi James Bug, hi Alexander, hi Sindhu. And by the way, my name is Shreyas. I'm your physics master teacher, your captain, your navigator on this channel. And if you want to know more about me, you can definitely visit on my Instagram. And today I have put up a very nice featured video of myself on the Vedantu channel. So have a look at it on Instagram and let me know your thoughts on it. I'm very good, Priyanshu. Hello, Joyce, and your Thalaiba is here. Hello, Alexander. And I hope you guys have hit the subscribe button. Now you will be only able to chat if you are a subscriber, and I'm so glad all the people who are chatting are subscribers, because that's the way you're going to stay notified about all the videos. And do not forget to hit the like button, because it shows that yes, you want more videos like this. And if you want more videos like this, you need to put up that smash on that like button. And guys, this is very important. Join the Telegram channel, because that's where you are going to get all the PDFs, the notifications, updates, all the relevant documents for your preparation. So let's begin with the class. And hello to every one of you out here. So let me get you guys on the screen. Sir, how much do Vedantu teachers earn? Good enough, decent, just, I would say happy. And more than that, I feel that here will really mean when we say that, we are teachers by choice. And many of us were in the software field. Many of us had good jobs, and yet we chose teaching because we love teaching. So yes, it's not like we make less, but we made good enough to keep a happy running family. Okay. Good evening, Avantika. Hi, Ankit. Hi, Dharni. Will you teach in Vedantu NEET Made EG channel? Yes, Sajid. On Vedantu NEET Made EG channel, I'll be teaching for NEET aspirants in English or Hindi majorly. So that's what it is. Namaste. I have physical education. Ankit, I hope you're practicing. This is how? Yeah? And what else is there? Okay. So let's do. Okay. What else? Yeah. PT exam. Sir, your screen looks like the one in the barber shop. I agree with you, Kishore. I agree. Yeah, so many me's out there. Hi, Umesh. Hello, Karthi. Sir, will this session help to revise the chapter or learn from scratch? Learn from scratch. We have another video, another playlist. I'll tell you which one you should watch. So go to playlist. You see, this is our channel. Go to playlist. Down, 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 down. 11th class. Nurture physics playlist. Click on this view full playlist. You see that? Right over here, all detailed classes. Newton's laws of motion, lecture 1, lecture 2, lecture 3, lecture 4, lecture 5, Minty quiz, problem solving, constraint and work per energy, lecture 1, 2, 3, 4, 5. So this is where you're going to learn the detailed one. This is mainly for your revision. Okay, bacha log, is that clear? Yes, there will be problem solving as well. Hello Daniela, welcome. Good evening Khushi. Hello everyone. I hope I did not miss out anyone. What is the hardest chapter in physics? I would say rotation. Then comes electromagnetic induction and magnetism basically. These are the difficult ones. Hi Hemant. Hi Sanchana. Hello Kishore. Tell about pedagogy. Pedagogy is basically an app, and we bought it. Basically Vedantu has collaborated and we have bought it. So you get access to all the hard copy material in the soft copy manner, so you don't have to pay so much. And when you are a part of Vedantu, you get free access to many books, e-books, which otherwise you have to pay and buy. So it's a part of Vedantu now. Okay, electrostatic efficiently. Watch my playlist. It's there. This playlist is there. Check it out. This playlist, Pathfinder playlist. Watch it. Within few days, you will be a master in it. Shall we begin, guys? It says in HC Verma, Rihan, whatever is there in HC Verma is not necessarily a part of JEE. Hi Preeti. Good evening, Anil. Hi. When will the class of this session in Vedantu NEET Made Easy channel be? I think it will be next week or maybe this weekend by Friday or something. Okay, cool. Let's begin then. Let's start the class. Now, what are the concepts that you need to revise in Newton's laws, in friction and circular motion? By the way, in today's class, we'll be mainly focusing on the dynamics aspect of it, not so much on the energy aspect, because I have a separate session on work power energy, collisions and center of mass, which is going to be, day after tomorrow or maybe after that. So you should know the 3 laws of motion. You should know what does FBD mean, how to draw it, what are the hidden things, what is the system, what is the meaning of external, internal forces, the 3 statements, how to apply them for pulley problems, wedge problems, spring problems, and all the different kinds of forces, be it weight, be it tension, how to find it, normal in different cases, be it wedges, be it circles, be it anything, how to solve problems on spring balances, spring force, etc. Then when you go to frictional chapter, you should understand what is the meaning of contact force, the 2 different types of friction, the laws of friction, coefficient of friction, and the angle of repose. This is where you should focus on. And when you go to inertial and non-inertial frames, you should know what is inertial, what is non-inertial, how Newton's laws are not valid in a non-inertial frame. The concept of pseudo force is also very important. And lift frame of reference is a standard set of problems that you get there. In circular motion, the kinematics aspect, the velocity, angular acceleration, tangential acceleration, centripetal acceleration, then the dynamics aspect where you have centripetal force, centrifugal force, then vehicle which is going on a circular track or a banked road, and then vertical circular motion or pendulums, be it conical pendulum or simple pendulum, those kind of concepts are also important. Let's start by revising this. Okay, so Ranveer, even if that question came right, you can still do it. It's not that difficult. I'll tell you why in a bit. Wait a second. See, when I say Newton's law, F is equal to ma, this is actually not the Newton's second law. How many of you know this? This is not the Newton's second law. What is Newton's second law? A lot of people get confused. They think this is Newton's second law. This is not Newton's second law. Newton's second law is actually F is dp by dt. This is Newton's second law. What's the difference? Is momentum is nothing but mass into velocity. Now m into v, these are 2 things, so product rule, so you will get this as m into dv by dt plus v into dm by dt, u into v rule. Yep. And dv by dt is m into a plus v into dm by dt, this is the mass change rate. Usually what happens is you just focus on this part, because usually what happens, this quantity is 0. Mass does not change. So that's why you usually write net force is mass into acceleration. But if there is a change of mass, then this v dm by dt term will also come. That's all. And that is basically sometimes also called as the thrust force. Now what happens is the thrust force concept comes in the momentum chapter in a very different form, that v dm by dt wala force. V dm by dt, often also called as the thrust force. It is also called as the thrust force, and that comes in the chapter of momentum or even in fluids, where you have a cross section and there are many particles which are coming out of it, or liquid coming out of that pipe, or many bullets coming out of a cross section. And if this area is A, and if the density of this flow is rho and the velocity is v, then the force which is exerted, which is the thrust force which is exerted is given by rho a into v square. So you can use this formula. So it is indirectly that bullets shooting problem, where many bullets or water is ejected from a pipe, how much force is exerted by such a system. That is also called as your thrust force, which is rho a v square. This is there. Okay, I hope this is clear. Hi Black Swan. Okay, so this is how it comes. Yeah, got it, guys? So now will you remember it? This is something which you should remember. This is the same thing. It comes from this only, V dm by dt. Okay. In June, will it be enough if I start my JEE 2023 preparation in June? Kishore, yes, June is tomorrow. And yes, you should start it. Definitely. You will be able to complete it. Will it be enough? Yes, it will be enough. But don't delay it further, bacha. Start it now. Okay. Now let's quickly start revising the different concepts over here. So first thing I want to talk about is basically the concept of system, then internal and external forces. Okay, internal and external forces, and equilibrium, or I would just say balanced forces. So balanced forces, balanced and unbalanced forces. Okay, so these are the concepts first we'll touch upon, and then slowly we will go to other things. Let us say that we have certain objects, maybe this, like this, like this, like this. I don't know, some crazy things are there. These are different objects. This is mass 1, this is mass 2, this is let's say mass 3, this is let's say mass 4, this is mass 5. Many objects are there. System is nothing but a collection of bodies. It's nothing but a collection of bodies. You can decide what is your system. It's up to you. You can make that choice, and your choice of system will decide how quick you will be able to solve the question. Sometimes the choice of system is so important. Without that, you will not be able to find the answer. I'll give you examples also, don't worry. So let's say I choose these things as my system. These things as my system. Then you will see that all the forces which are there within the system, oops, one second, like the forces between them, or the forces between them, or the forces between these two, these are called as, what are these called as? These are called as internal forces, and these forces, like between these two, or 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 between these two, these are called as external forces. Remember, internal forces cannot change the momentum of the system. Very, very important. Internal forces can't change the net motion of the system. The best example of that, if you're standing on a scooter and you push the scooter, standing on the scooter, you will never be able to push it. If you stand on a bullock cart, imagine there is a bullock cart and a bull is standing on the bullock cart. This is your bullock cart. This is the wheel. And imagine a bull standing on it. Okay, this is our bull. Okay, so do you think this bull will be able to pull the cart? No, because the forces which it is applying is a part of that bull plus cart system. But if that same bull was here, okay, so this is our bull. Oh, yeah, this is bull, right? Yeah, this is how it is. Okay, this different bull, if it pulls like this, then when it is applying the force on the ground, the ground also applies an equal and opposite force. Now ground is not a part of the system, so that force becomes an external force, and that's why the bull is able to pull it. Makes sense, right? Yes, Karthi, questions are also there in the system, in this session. Yep, it is. Oh, okay. I hope this is clear. Fair enough. Now that you have understood this much part, let's talk about also balanced and unbalanced forces. So if at all you see that, okay, I need to get rid of this. Okay, if at all you see that this is a system and there are some external forces acting on it, F1, F2, so on and so forth, then if F1 plus F2 plus Fn is equal to 0, then the system is said to be in equilibrium, and these forces are said to be balanced forces. Balanced forces. If they will not cancel each other, it is obviously unbalanced forces. Also, one last point before we go ahead. Whenever we talk about external forces, should we show the forces acting by the system or on the system? Put it up in the chat box. What do you guys say? Whenever we draw a free body diagram or whenever we show external forces, should we show the forces acting by the system or on the system? This is very important because many people get confused because you do not know what you should draw. Or is it both? Or is it both? Come on, tell me. You should start right now, Kishore. I mean, there's no point asking. Okay, by, on, people are confused. Well, whenever you show external forces, guys, it is always the forces on the, this on word is on the system. Always on the system. On the system. Never by the system. Example, I'll tell you an example, guys. Hold on. Imagine I show the free body diagram of Pandu. I show the free body diagram of Pandu. He's standing on the ground. Okay, he's standing on the ground. Now, when I show the free body diagram, and let's say I show mg or weight, this weight is acting on Pandu or by Pandu? It is always acting on Pandu. When I show normal, it is acting on the Pandu, on the system. If I show the free body diagram of Earth on which he is standing on Earth over here, then on the Earth, there will be weight like this. Oh, why is there weight like this? Why is there weight like this? Because if on Pandu weight acts downwards, then on the Earth the weight acts upwards. And if on Pandu the normal acts upwards, then on the Earth the normal will act downwards. If I've seen this with many students, they make a mistake always. I ask them, if weight is the action, what is the reaction? And many people, including teachers, I have conducted so many interviews, they say, oh, this is action, this is reaction. Aha, so simple. No, that is not correct. If this is action, this is not reaction. If this is your action, then this is your reaction. This is your reaction. Force acting by the Earth on the Pandu, force acting on the Earth by the Pandu, and vice versa. Similarly, normal is acting on Pandu by Earth. This normal is acting on Earth by Pandu. I hope this is clear. Is that understood, guys? Is that understood, guys? So this is how Newton's third law works. So same way, if this is called action, this normal is called reaction. This is Newton's third law. Everybody clear about this? Understood how action and reaction works? Can we go ahead? Ranveer, I am already sharing it, Ranveer, on our Telegram channel. So make sure you are a part of the Telegram channel. Link is there in the description box. Over there you get the PDF, so you can download the PDF, take screenshot or save it on your hard disk wherever, or you can take printouts also. It's up to you. Okay. Having said this, let's talk about the laws of Newton's laws of motion. So I'm going to keep it brief. So the first law being, if net external force is 0, basically balanced, then the system is going to be at rest or move with constant velocity. Basically, acceleration will be 0. This is what the first law talks about. The second law is net external force plus any other forces which will later on study like pseudo forces will be equal to the mass into acceleration of that system. This mass is of the system, acceleration is of the system. These forces are always external forces, never show the internal forces. So this is basically for your unbalanced force. This is your unbalanced force. Because when the forces are balanced, the system either stays there or keeps moving with constant velocity. This is for your unbalanced force. And Newton's third law is all about the force acting on one by 2 is magnitude wise equal to force acting on 2 by 1, but direction wise it is opposite. Action, reaction. So if I call this as action and this will be basically reaction, will these two forces cancel each other? Can these two forces cancel each other? Think about it. Will these two forces cancel each other? Definitely they will not, because this is on 1, this is on 2. They are acting on two different bodies. So hence they cannot cancel out each other. Keep this in mind. Very, very important. Okay. Second important thing which I want to talk about over here is free body diagrams. So keep certain rules in mind whenever you are solving Newton's laws problems. One of the rules that you can first of all think about is show all external forces, external is very important, never internal, acting on the system. System is what you choose always. Also show the acceleration, which is basically the effect of all these forces, if any. If it is not accelerating, just mention the word rest so that you know that the forces will cancel out each other. Then choose your axis, and once you choose the axis, you're going to basically resolve all forces or acceleration. So accordingly, you're going to resolve everything, and then in every direction, you're going to say net force in the x direction is mass into acceleration in the x. Similarly, net force in the y direction is mass into acceleration in the y direction, and similarly for z direction. If pseudo force is there, you have to also include pseudo force like I have shown over here. Now, if needed, now these are some external extra rules. Make as many equations as many variables. Now, where are you going to make equations from? Some of the ideas that I can give you guys is constrained motion. Sometimes it could be work power energy, sometimes it could be circular motion, sometimes it could be collision, sometimes it could be kinematic equation. So whatever you have learned or whatever you have seen in the chapters ahead, all those things can be used to make additional equations. Sometimes it could be pure geometry, sometimes it could be a value which is given in the question. Read between the lines and make as many equations as needed to solve the question. Keep this in mind. Is that clear, guys? Understood everyone about this? Everybody clear about this? Let me know. Oh my god, what are you guys doing? Yeah, come on, focus on the questions, focus on the theory, focus on the class. Don't focus on each other now. Yeah, 150 marks, 98, 97, close to that. Yeah. Okay. Now that we have spoken about FBD also, let's talk about the different kinds of forces. So starting with weight. Okay. So obviously I'm going to keep this quick. So if you have any mass, the weight force is always going to be mg, and weight is always expressed in Newton. You can also express it as kgf, not the movie 1-2, but it is kg force. So if I say 2 kg force, it means the weight exerted by 2 kg mass. So 2 kg force means 2 into g, which is 20 Newton roughly. This is what weight is all about. Then talking about next force, which is normal force. So the normal force is always going to act perpendicular to the surface. So if there are two surfaces which are in contact, this is surface 1, this is surface 2, surface 1, okay, this is surface 1, this is surface 2. The normal force will always act perpendicular to the contact. So this is normal, this is also normal. Why am I showing two normals over here? Because it depends which body you are taking. If you take body 1, then normal taken will be this one. If you take this body, normal on that will be this. This is action, this is reaction. Newton's third law. Always it's the perpendicular force which acts on it. Whenever they use the word loses contact, the moment they use this word, understand it just means that the normal force has become 0. Keep this in mind. Is that clear? Exercise problems are very good for revision. Yes. Okay. जयंत वी प्रो लाइट में मेरे को अभी याद नहीं है, बट आई विल चेक इट आउट एंड लेट यू नो. मेरे ख्याल से शायद वहाँ पर रोहित सर हैं, शायद युधिष्ठिर सर है, और सूरी सर भी है, मोहित सर भी है. काफ़ी अच्छे टीचर्स ही है जहाँ तक मेरे को याद है, इन्हीं में से कोई है. ओके, नेक्स्ट वेट नॉर्मल डन. लेट्स गो टू टेंशन. Tension force. Now tension is always going to be certain important things. One second guys. Yeah, tension is always going to act outwards from the string element. So if I have this as my string element, you will always see that the tension will always pull the string. So it is always going to be the pull. This is T and this is T. Very important for massless string. For massless string, tension is same throughout. It is constant. It's never going to change for a massless string. Keep this in mind. Okay? Okay. Next important point, the moment they use the word that it is slack, what is the meaning? Or it has become loose, the string becomes loose, or the string has become slack. It just means that the tension has become 0. Keep this in mind. Also, you might see certain problems where the string itself has mass. Mass was 0. Here the mass is not 0. In those cases, you will see that the tension is going to be different. It's going to be different. Here you are going to see T1. Here you're going to see T2. And tension changes because there is mass in the string. That's something which you should keep in mind. Is that okay, bachcha log? Keep this in mind. Okay. Now, having said this, let's go to the next kind of force, and that is your spring force. Spring force. So, for spring force, again, let's draw the spring. You always have something called as the natural length of the spring, and you have something called as a spring constant, which completely depends on the shape, size and material of that spring, and depending on how much you extend it, you get the force. So if you extend it by x, the force acting on the spring magnitude wise is just going to be kx. It depends whose free body diagram you are drawing. So the force can be either this way or this way. If you pull the spring, on the spring you are applying the force this way. The spring on the body will apply the force the opposite way. So I do not generally put a minus sign because I understand it that which direction the force will act. So I generally do not put the minus sign over there. Okay? If K is more, the spring is very stiff. If K is less, the spring is less stiff. Okay. Now based on this, you also get problems on spring balance or weighing machine. So whenever you see a spring balance and they ask you what is the reading of that spring balance, okay, what is the reading of the spring balance, or sometimes even weighing machine, then remember, whenever such a question comes, replace the spring balance, convert that spring balance into a string. What do? convert it into a string, and then check what is the tension in it. Then check what is the tension in it. Whatever is the tension becomes the reading of the spring balance. That's it. Very simple. Whenever you see a spring balance and they ask you the reading, forget that there is a spring balance, replace it with a string, check the tension. If it is, let's say, 70 Newton, then what will be the reading shown? 7 kg force or 70 Newton force, or you can write it as 7 kg. That's all. That's it. Okay, I hope this is clear. Very, very important. Vishnu, Chitan, Ramesh, you're not missed much, but you have missed decent. Don't worry, you can catch up. You can join in from now, but watch it live. You can even watch the replay later on also. Don't worry about it. So these are the problems which involve the reading related questions. And similarly, you might have questions on weighing machine. So you might be given that there is a weighing machine. Okay, weighing machine. Weighing machine. And there is something kept on it. It might be accelerating. I don't know. Many things could happen, guys. So there could be some object and they will ask you what is the reading shown. So whenever they again ask you what is the reading shown, what is the reading shown on it, always try to figure out what is the normal acting on the weighing machine or by the weighing machine. So just try to always figure out what is the normal. That normal always becomes the reading. Okay, these are the weighing machine related questions. Same thing in lift also, Hari Prasad. So even if the spring balance is in a lift, forget that lift now. Just replace that spring balance with a string inside that lift. So then solve the problem normally as if it was a string. If it was a weighing machine inside a lift, inside a moving truck, and friction, normal, spring, whatever is there, just always find the normal. The normal force becomes the reading in this case. Yes, Monica, this is sufficient. Yes, Bacha. I hope this is clear. If you cut the spring, then what happens is, okay, I'll just show it to you in another slide maybe. So these kind of questions also come. Sometimes the spring is cut. So let's say for example, you have a spring and a mass and a spring and a mass. Example, this is M1, this is M2, this is K2, this is K1. Let's take it case by case and I want your help in this. Hi Sonalika. Okay. Darshini, that's what I'm doing. Observe now. Imagine I cut K1. K1 is cut. So how will the diagram look like? Well, K1 is cut. So just M1 will be there and just these springs will be there, which is K2 and this is M2. Whenever you cut a spring, that spring completely gets destroyed. That's it. It suddenly comes back to its natural length. That's it. You can just forget that spring. Because it has been cut, that's it. The spring instantaneously loses its deformation. Comes back to its natural length. So forget it. Now, meanwhile what happens? The other spring will not deform instantaneously. It takes some time. Now if you look at this question, don't you see that there was some weight acting downwards, which was M2G on this block. There was some spring force upwards. So this spring force by the second spring will be equal to M2G. Can you see that? Spring force by this spring will be M2G because this is at rest. Acceleration of second block is 0 as of now. The same spring force will continue, and that's why on this block, apart from M1G, there will be also the spring force which is acting downwards. Spring force which is acting downwards. And here there is a spring force F1. This will be balancing both of them. So it will be M1G plus F2. So it will be nothing but M1 plus M2 into G. This is what this spring force will be. Everybody fine till this point? Everybody fine till this point? I hope this is clear. Now what happens is you have cut the upper spring. So this force will vanish. That's it. F1 will become poof, gone. But other forces remain. Like M2G will remain. M2G will remain. These forces will not change because the spring will take some time to compress or relieve its extension or change its length. So these forces are still going to be there. These forces are still going to be there. So M1G will be there. even F2 will be there, and even M2G, which is equal to F2, will also be there. Now think and tell me, will M2 remain at rest or not? Will M2 remain at rest or not? Think about it carefully and let me know. Because if you look at this diagram, F2 is still there, M2G is still there. These two forces were cancelling each other and it was at rest. Hence, even in this situation, acceleration will still be 0. Acceleration will still be 0. Is that making sense, bacha log? Hello Malvika 13. Good evening, bacha. Hi Nitesh Kumar. Hi Shaikh Shaikra. Yes, it will be at rest. This guy was at rest here. But do you think he will be at rest here? Aha. Look at this. M1 was balanced by a downward force and an upward force which were equal. But this force went off. Do you see that there is an unbalance? Hence, it's going to accelerate downwards. And that will be nothing but M1G plus F2 divided by its mass, which is M1. So there will be an acceleration here. Is that clear, everyone? Clear? Okay. Let's take the this other scenario, my bad. So what if what if K2 is cut? If K2 is cut, then what will happen? Well, this is the roof. That spring on the top is intact. This block is there. This spring has gone poof, gone. This is M2. Now try to draw the free body diagram. Now see what and all will come. Okay. They will not cancel each other, M1? Yeah. Yeah, Sunena, they cannot cancel because this force has gone. Only one force is there. Hence, you will see it will accelerate. Hello, MK. Now, if you look in this case, M2 will experience the normal weight, which is M2G. But the spring force between them, F2 will vanish. Poof, gone. So F2 has vanished. F2 has vanished. M1 will experience only M1G. Only M1G. F2 has vanished because this spring K2 was cut. From the top, this spring will still be extended. It will take some time to change its length. So still the force will be equal to M1 plus M2 into G. Now think and tell me what will happen to M2. There is only one force on M2, which is M2G, which is the weight. So hence, won't this guy accelerate? It will be M2G by M2, which is G, which is nothing but a free fall. Everybody clear about this? Hi Monica Naravade. Good evening, Bachalu. Isn't it going to be free fall? That's it. Nothing is there from the top. It's just going to be free fall. What about this guy? Do you think this will be at rest or not at rest? Come on, put it up in the chat box. M1 will be at rest or not at rest? Sai Sankalp, you're a little bit late, but it's okay. Join in. It will be at rest? Okay, come on, think. Hi Yogesh. Oh, there you go wrong, guys. Guys, see now whether it is balanced or unbalanced. M1G down, M1 plus M2G up. M1G down, M1G plus M2G up. Is it going to be balanced? Very good, MK. It is not going to balance. It is going to go up. See, directly you have to see over here. In fact, the unbalanced force will be how much? M1G plus M2G up, M1G down. How much is the unbalanced? What is that force which is not cancelling? What is that force which is not cancelling? Obviously, it is M2G. M1G cancels, only M2G is there. So it will be M2G by M1. This will be the acceleration and it will go up. It will go up. Hi Sumna. Is that clear how to solve these spring questions? Very good Hari Prasad, very good Sanchana. So these kind of questions are very important. You should know how to solve them. It's all about free body diagrams. It's all about what you take as a system. It's all about whether you realize when you cut a spring, that force vanishes, the other spring remains intact. Dr. Tech, why don't you leave a comment? I will definitely reply to you. I'll definitely reply to you after the session is over, or wait till the session is over. I'll reply to towards the end. IT aspirant, welcome, bacha. No worries. Let's go to the next part. I think what is remaining? Yeah, weight, normal, tension, spring, done. Let's talk about contact force. Contact and friction both come together. Okay? Contact and frictional force. So let's say for example, you have a body like this, okay, of mass m, and this is your surface on which it is resting, moving, whatever. Then you have something called as the contact force. This is contact, which is the resultant of all the forces which act at the surface. Is the resultant of all the forces which acts between the two surfaces. It could be at an angle, it could be not at an angle, I don't know. But I've just shown a random direction. Now there are two components of these forces. One is perpendicular. The other one is parallel to the surface. That component which is perpendicular, the other word for perpendicular can be orthogonal, other word for orthogonal can be normal, 90 degrees. So that's why this is called normal force, and the one which is parallel is called friction. So keep this in mind that in reality contact force is the resultant of normal force plus the frictional force. Otherwise, magnitude wise, it is root of n square plus f square. So this is basically your contact force magnitude. So a lot of people do not know about this, but now I'm telling it to you. Stress everything comes in solids, Daniela. Thank you, Shruti Babu, so much. Welcome. So glad. Okay, fair enough. All right. Now let me tell you the two cases of friction which you should know, and also the graph of it. And obviously friction is divided into two types. One is your static friction, one is your kinetic friction. Static friction, usually the symbol is Fs. Kinetic friction, usually the symbol is Fk. Certain things which you should know about static or kinetic friction are: number one, static friction opposes tendency, not actual motion, because static means the surfaces are not moving yet. If they're not moving yet, what will it oppose? It will oppose its tendency. What does it want to do? If I keep a box on an inclined surface and I see it is not slipping, there is still friction, even though it is not moving. Why? Because there is a need for the box to move. It wants to go down. So it opposes what it wants to do. If it wants to go down, it will act up. If it tries to go up, it will act down. That's what it is. I hope this is clear. Okay, it opposes tendency, and this is self-adjusting force. Self-adjusting force. Keep this in mind. So if the tendency is there, force will act back. If the tendency is here, force will act here. And always this force is going to be less than equal to the limiting frictional force, which is Fs max. And okay, just one sec. Somebody was saying I cannot see. This is just opposing tendency, bacha, nothing else. So this is less than equal to Fs less than equal to Fs max. And what is the meaning of Fs max? It is nothing but static friction coefficient into n. So this is what friction will lie between. It is self-adjusting. It can take any value between 0 and mu Sn. Mu Sn is the limiting value, limiting or maximum frictional force which it can bear. Beyond that, it's beyond its understanding, it's beyond its capability, it will slip. It will slip. Hi Rama, hi Pushparaj, hi Akshita. Okay, next thing, talking about kinetic friction. What will it oppose? It always opposes relative motion. Actual motion it opposes. And it is not self-adjusting. It is always a constant force. Constant force. Okay? Keep this in mind. This is always constant in nature. And the value of it is mu k into n. It's the same. It doesn't matter how fast or how slow you are. If you are moving, it will be mu into n. Keep this in mind. And there is a very important graph on this which you should definitely know. That is this one over here. This is basically your what do you say, friction. This is your friction on the y-axis. This is your pull or your push that you are applying. This is 0. The graph starts from here. If you increase your push, you will see your friction will also adjust accordingly. It will reach a maximum value. This is basically your Fs max, and the moment it slips, the friction will drop down. It will drop down abruptly and it will be constant. This is basically your Fk value. This is how it goes. Okay. Yep. Yes, this will be helpful for BidSat because it all has the same theory in NED Cruise. I doubt Sai Sankalp. Okay. Yep. So guys, remember that be it IIT, be it NEET, be it BidSat, be it CET, all the exams have similar theory, almost similar kind of questions. Only the pattern, number of questions and difficulty, that's all that changes. Otherwise, you prepare for one thing, you prepare for everything. Else you would have coaching classes separately for BidSat, separately for CET, separately for UG EEE, separately for VIT EEE. Nobody joins those classes. Once you are preparing for JEE or NEET, you know that you are preparing for everything. Yeah, IIT Hyderabad is very good, bacha. Sir, will friction increase with acceleration and velocity? Definitely not. See this word? Constant. Kinetic friction is always a constant. Keep this in mind. Alright? Okay. Great. Now, let's move to other parts like say for example, yeah, friction is done, relative motion, everything is done. Yeah, let's go to angle of friction and also the pseudo force concept. So angle of repose, this alpha is called angle of repose. Basically it is that angle for which, or rather till which, I'll put the word till which the object doesn't slip or basically slide. So it is that angle, and tan of alpha is equal to mu s. So that's how you find the relationship of alpha or the angle of repose with the coefficient of friction. Keep this in mind. I hope this is clear. Oh man, thank you, Jishnu Manoj. That's how it is. Yeah, a lot of great thinkers have very good handwriting. Yep. Okay, clear. Next thing, talking about pseudo forces, that is also very important. Pseudo forces. So when we talk about pseudo forces, remember you always have to bear in mind that there will be something called as a non-inertial frame. What is the meaning of non-inertial frame? Sir, will friction change with area? No, not much. So what is the meaning of non-inertial frame? Non-inertial frames are those frames which basically accelerate. Example, lift or accelerating car or braking bus. These are examples of non-inertial frames of reference. And whenever you have a non-inertial frame of reference and you are looking at some object or some system, keep this in mind, you have to apply something called as the pseudo force. So if I know that the non-inertial frame is, let's say, for example, accelerating this way, if this is the acceleration of the non-inertial frame, then on the system you should show a pseudo force exactly opposite, which will have a magnitude of mass of that system into acceleration of that frame. Always remember that. It is always opposite to the acceleration. If acceleration is here, pseudo force will be here. But whose acceleration? The acceleration of the frame. And the best example comes for the lift. So lift related problems also are very important. Example, that you have a lift and let's say it is accelerating up with A, and imagine a lift which is accelerating down with A. If that's the case, and if you have a mass or some body over here and in here, so what is the direction of the pseudo force? Think about it. Pseudo force always acts opposite to the acceleration. So in this case, the pseudo force will act like this. So it will be nothing but mass of the body into acceleration. In this case, lift is accelerating down. The pseudo force will act like this. Fp will be mass into acceleration. But apart from that, do not forget that there will be another force, and that is your mg, which is your weight. So mg will be here, and here in this case, mg will be here. So you will notice that in both the cases, pseudo force is sometimes helping, sometimes opposing. In the first case, mg and pseudo force are in the same direction. If they are in the same direction, that means it will accelerate faster. And in this case, mg and pseudo force are in opposite direction. Net force will be less as compared to this one. Keep this in mind. I hope this is understood. So these kind of questions are also very common. Okay, so bear this in mind. Let's move on to the next one. Let's move to circular motion concepts as well. Fair enough, guys? Thank you, Samina Kausar. Means a lot. I'm so glad that we're crossing borders and reaching lots and lots of nooks and corners of different countries. Yesterday we had people from, I think, Turkey. We have James Burke from, I think, US. We have people from Australia. We have people from Africa, and now we have people from Pakistan too. Hi, Maya. Okay, chalo, let's move on now. Let's talk about circular motion kinetics. So, circular kinetics. Circular kinetics. Let's talk about it. So, let's start by drawing obviously a circle or a curved path. It will have something called as the radius, and it will have certain velocity. Let's say this is v, okay, and it will have some angular velocity, okay, and it will also have probably some angular acceleration, okay. And let's see what is the relationship between all of them. First of all, relationship between v, omega, alpha, all of this. V is also called as your tangential velocity. Tangential velocity. And this v is basically omega into r. It's also easy to see that the length of the arc covered is radius into the angle displaced. The angle displaced. L is r theta, v is r omega. Very, very related to each other. Same way, along the path, this particle can also have something called as the tangential acceleration, and that tangential acceleration is given by very similar formula, r into alpha. You can see all the length terms are here. Here you have angular terms, and this is radius. It's consistent. It is consistent. Oh, that's great to know, Daniela. You're watching from Ghana. Aviti Shetty, Swalpa Kannada gotu, Tumba Kannada gotilla. Okay, fair enough. Moving on to the next part. Great. Now, what is this tangential acceleration? Tangential acceleration is always responsible for changing the speed of the particle. Speed. It is basically going to change the speed. There is another kind of acceleration, and that is exactly perpendicular to the tangential one. It is towards the center, and that centripetal acceleration, okay, this is centripetal acceleration. This is responsible for changing the direction of the motion. So it always, the perpendicular component changes direction, the component along the tangent changes the speed. And this value AC is v square by r, you can also write it as omega square into r, one and the same thing. Okay, you can write it in any possible way that you want. Also, some more relationships, just like v is dx by dt, a is dv by dt, rate of change of velocity is acceleration, rate of change of displacement is velocity. Same way, angular velocity, you will see that omega is d theta by dt, which is always expressed in radian per second, and alpha, which is angular acceleration, that is d omega by dt, which is expressed in radian per second square. Keep this in mind. Fair enough, guys? Cool. Jayajinkya, I hope you are revising few concepts through this. All right. Now, these two accelerations together will produce the resultant acceleration A, and this A vector is basically the resultant of the centripetal plus the tangential. Magnitude wise, it is root of AC square plus AT square. Keep this in mind. This is your total acceleration magnitude wise, and vector wise it is the vector sum of AC plus AT. This is total acceleration, different from just centripetal and tangential. So net acceleration has two components. One which is along the path gives you the speed change rate. One which is perpendicular to the path gives you how it is changing the direction. Okay. Last point over here, especially with regards to uniform circular motion. In uniform circular motion, is velocity constant? Yes or no? Put it up in the chat box. Is velocity constant or no? We are going to solve lots of questions, Shreyas, don't worry. And if you have any specific type of problem which you need me to discuss, just like the spring cut question, I'm going to do that. No, velocity is not constant. Very good. Because velocity changes direction, only speed is constant. Very good. So in UCM, you will see the magnitude of velocity is constant. Direction changes continuously. So keep this in mind. And omega is 2 pi by time period, which is also 2 pi f, where f is the frequency, where f is 1 by t. This is usually expressed in hertz or in RPM, however you want to write it. F is the frequency. This is your angular frequency, angular speed, which is 2 pi by the time period. Very useful in many questions. Keep this in mind again. Okay, so that's all about uniform circular motion, which you should know. Speed is constant. Okay, this was circular kinetics. Now let's move to circular dynamics. Circular dynamics. Circular dynamics. So in this we are talking mainly about the forces. So again, let us just say that we have a body of mass m, and let's say it is going in a curved path. So we know that it always will have some kind of maybe tangential and maybe some kind of centripetal acceleration, and it will also have a total acceleration in this way. If there is acceleration, there must be some unbalanced force acting on it. So that force or forces which are in the direction of the tangent or along the path, that is called as the tangential force. Those forces which help in changing the direction or which are along the centripetal acceleration, those are called centripetal forces. The resultant of these forces will give you the net force. So strictly speaking, Fc is mass into centripetal acceleration, and F is equal to mass into total acceleration. Ft is mass into tangential acceleration. That's it. That's all that you need to know. It's just like solving a normal Newton's law problem. Centripetal acceleration has a value of mv square by r, or sorry, v square by r. Centripetal acceleration has v square by r or omega square r value. A lot of people I have seen, they say, oh, centripetal force I know, sir, it is mv square by r. All those people who say that centripetal force is mv square by r are not really understanding physics. I'll give you an example. Let's take some example, maybe a very weird kind of example. Okay, just observe this. Imagine this is the sun, the hot sun. This is the earth. Is there some kind of force between the sun and the earth? All right, Shreyas, I'll help you with that a little bit, definitely. Pseudo force and pendulum related problems. Hold on. Is there some kind of force? Yes, there is gravity between them. Let's say I have a big spring and I connect a big spring between these things and the spring is extended. Gravitation is there. Hypothetical spring. This is just to explain you the concept of, centripetal, tangential and all these things. And let's say there is solar dust, solar storms, wind, rocks, God knows, some random things. So there are these dust particles which will create some kind of resistance to the motion. And the earth is definitely trying to go in a circular path like this. It's trying to go in a circular path like this. Okay, let's try to understand what are the forces. Yes, so like you said, there is a there is a gravitational force. So like this. So the value will be G m1 m2 divided by the distance square. Correct, guys? G m1 m2 divided by r square. Will there be also a spring force? Will there be also a spring force like this? The spring is extended, let's say, by x. Will it not be kx, guys? Everybody with me? There is one more force which will be acting on it, and that will be the resistance of all of them, and that will be nothing but some resistance force. I don't know, I'll just put it as FR. I just don't know what is that resistance, but just putting it, that's the resistance force. Okay, if it is given to me as a value 100 Newton, 200 Newton, 1000 Newton, I'll put the value. Now, is there any other force that is missing? Should I show the centripetal force? Yes or no? Put it up in the chat box. Should I now add the centripetal force? Yes or no? Come on, put it up in the chat box. I want to know what you guys think. Should I show the centripetal force? And if I should, where should I show it? It's going to be very interesting answer from all of you. Sunena saying yes. What about the others? See this answer. Pranav also saying yes. Sonalika saying yes. Darshini saying no. Interesting. Joy saying yeah. Jay also saying yeah. Okay. See guys, that is why you should always learn from the right teacher. You should always learn from the proper sources. That's when you will never make conceptual mistakes. The answer is you will not show centripetal force because there is no centripetal force, which is actually a separate force which is acting over there. Centripetal force is not like a new force, normal, tension, friction, gravity. Nah, it's just a name, it's a title given to the component of the forces. That's all. So, technically, this force and this force together is the centripetal force. So, just like you solve a normal Newton's laws problem, I know that there will be some kind of acceleration towards the center. So, let's say there is some centripetal acceleration over here, and maybe there is some tangential acceleration because of this force, like this. Imagine. So, what I will say is G net force is MA. That's all, guys. Just 1 second. Net force is mass into acceleration. Just keep this in mind and see what will you write. G m1 m2 divided by r square plus kx is equal to mass into centripetal acceleration. Not just that, you will also say the resistive force is mass into tangential acceleration. So guess what is in store for you? This is your centripetal force and this is your tangential force. So centripetal force is not a new force. It's not, I'm not talking about the orbit and all, Sushant. I'm just worried about FBDs. This is the tangential force. Did you now understand it? Clear? It's not a new force. It's just like solving normal Newton's laws. Why people do not get circular motion? I'm giving it to you in one line. Because you are taught usually in coaching or by many teachers the show centripetal force mv square by r m omega square r. Nah, I say if you learn Newton's laws, you should know circular motion. The only thing you should know is acceleration towards the center is v square by r or omega square r, and tangential is changing the speed. That's all. It's just a name, subscript. Everything, FBD, resolving, everything else is the same. Okay, fair enough. Let's move on. Oh, I wanted to show you one more thing. I forgot, guys. Oops, sorry. I'll just get it back. No problem. A sun, spring. Oh my God, Earth. All right, and you had your GM. Am I writing on the okay GM1 M2 divided by R square. You also had KX over here, I believe, and you had this path going like this. Now all this was fine if you're sitting outside and this was an inertial frame. This was inertial. Sometimes you are on a merry-go-round, sometimes you are in a rotating bus, sometimes you are in a car which is going on a curved track, sometimes you are in a lift which is, or a what is it called? Giant wheel. Yeah, you're in a giant wheel. So when you have a rotating frame of reference, things change. A rotating frame of reference is a non-inertial frame of reference. Now, Sushant, I don't have undo option. I'm not sure about that. Okay, so basically, in that case, when you have a non-inertial frame, you should have a pseudo force. And imagine you are going round with it like this. As the earth rotates, you are also going round with it. Will you see the earth at rest? Yes or no? Put it in the chat box. Yes, I'll be going to banking also, Himanshu. Hold on. If you're rotating with the earth like this, what will you see? The earth is at rest. Yes, correct? Okay. So now I'm going to say that the earth is at rest. Velocity is 0 because I am in the rotating frame. I am in the rotating frame. The moment I am in the rotating frame, V is 0, V square by R is 0, centripetal acceleration is 0. Now you'll be like, sir, Kx plus G m1 m2 by R square is equal to what, sir? Wait a minute. You are in a non-inertial frame. In a non-inertial frame, what will come? Pseudo force. Where will the pseudo force come? Always for a circular motion, outwards. So you need to put the pseudo force out here, and that pseudo force is basically going to be outwards. This pseudo force is called as the centrifugal force, and this value is m omega square r or mv square by r, whichever value you want to use. mv square by r or m omega square r. Is that here? Okay, I think if that r is not visible clearly, let me just put it up right. Yeah, mv square by r. Now solve it like a normal Newton's problem. Oh, it is at rest, so it is balanced. It is balanced. And if it is balanced, then pseudo force should be equal to kx plus gm1 m2 divided by r square. And what is pseudo force? Pseudo force is nothing but mv square by r, or you can put m omega square r. One and the same thing. Now think about it. When we try to solve the problem from an inertial frame, then when we try to do it, what did we do? We just said kx plus g m1 m2 divided by r square is mass into centripetal acceleration, and centripetal acceleration was v square by r. Tell me, is there any difference between this equation and that equation? Tell me, is there any difference between this equation and this equation apart from the colors? Come on. Yes, Jatin, there is a spring between sun and earth in my world. Tell me guys, is there any difference? No, right? So what did you learn? Which method is good? Both are good. Anything is correct? Anything is wrong? Both are correct. Nothing is wrong. Which one will you choose? It's up to you. So what should I do? Try it by both the methods. You should have the knowledge of rotating frames and inertial frame. Understood? Clarity? So in a rotating frame, the centrifugal force comes. If you're rotating with it, if you're not rotating, you're outside, acceleration comes. That is the only difference. So keep this in mind. This will come only in inertial frame, not in non-inertial frame. So I'll just make a pointer over here. Probably just make a pointer over here. Which color do I use? Let's use yellow, dirty yellow. So in a non-inertial basically rotating frame, the pseudo force is basically called as the centrifugal force, and it has the value of m omega square r or mv square by r, and it will always act outward. Keep this in mind. This is the value. Yes, that is why I have brought this 0 to superhero series. Okay, so this is something which you should clearly know about. Let's move on to the next one. Let's talk about a vehicle on a curved road. This is very important. So you have a curved road like this. It has radius of curvature, and let's say this is your vehicle. Okay, this is your vehicle. Cool. And it's going inside the plane, so it has some velocity v. Okay, it has some mass m. There is some coefficient of friction, etc. When you show the forces, what kind of forces come? Obviously one mg comes and one normal comes, and friction, where does friction act? Come on guys, let me know in the chat box. These kind of questions have in common. Where does friction act? Outwards or inwards? Outwards or inwards? Yep, it has to act inwards. Yep, and this is static in nature. And yes, apart from that, you will not forget the centripetal acceleration. And I think because it is going with constant speed, the tangential acceleration is 0 because speed is constant. Assuming that the speed is constant. This is how it is. Now quickly tell me, what is the centripetal force in this case? Put it up in the chat box. What is the centripetal force? Is it normal? Is it mg? Is it friction or something else? Put it up quickly. Now you should know it because you have attended the class from some time. What is the centripetal force? Omar, Adnan, the 2023 sessions have already started on the platform. In fact, I am taking the batches. So please make sure you join the 2023 batch where I am teaching, and all the other teachers are also there, all your favorite teachers. So it has already started. And my previous year classes are already there in the Pathfinder series. You can watch that. But we'll be not starting any long-term batch on YouTube because it has already been conducted. But I'll be doing, problem solving series, advanced series, and one-shots, those kind of things. But not the long-term batch, because the long-term batch has already started on our platform. Yes, friction is the centripetal force, and one will obviously say that Fs is equal to mass into centripetal acceleration. That's all. That's how the equation goes. And after solving, you get that the Vmax value is root of mu s r into g. So this is the maximum speed with which you can go. If you go exceeding that, you will slip outwards. Very good. Now you also get a case of banked road. So this is the angle of banking. This is usually called the angle of banking. And again, you have your vehicle. Okay, 1 second. This is going on a banked road. This is again the radius R. All right. So our vehicle is going on this curved road with some velocity V. Okay. So here you get again two kinds of speeds which you should know. One is optimum speed, for which it has been basically designed for, and these kind of questions, the optimum speed is nothing but root of Rg tan theta. Rg tan theta, theta is the angle of banking. If you go at this speed for which it has been designed, you will see that the frictional force acting will be 0. Very important. So there will be less wear and tear of the tires. So there is very little wear and tear because there is no frictional force. You're just making sure there is adequate amount of velocity for it to not slip or not fall down, and you can maintain the balance over there. Now, there is also another kind of velocity which you should know in this case, and that is your maximum velocity. Anybody knows the formula? Well, there is a short trick to remember it. It is just Rg tan theta plus alpha. If you forgot what alpha was, alpha is your angle of repose. Angle of repose. So what happens is when you expand this, it just becomes root of Rg tan A plus tan B is tan A plus tan B upon 1 minus tan A tan B. So it will become tan theta plus tan alpha. Tan alpha is mu upon 1 minus tan A, which is tan theta, into tan B, which is tan of alpha, which is nothing but mu. So this is what is there in most of the books, but I prefer remembering it in this way. I feel you should do the same. Why does a two-wheeler rider have to lean vertical? Why is such leaning required for a four-wheeler? Okay, I'll tell you that. Hold on. Is that clear, guys? These are the important formulas which you should know. Okay, now talking about Jay Ajinkya's doubt, why do we need to lean when we are bending over a curved track, and why not for a four-wheeler? What happens is, if you take the separate FBDs, let's say this is our two-wheeler from behind. Okay, this is our biker. I hope you can see him. And this is, let's say, our car. From behind, guys. This is from behind. Okay, this is from behind. Those are the red lights. I hope you can visualize it. Okay, when you are going in a curved track, what you need is basically a centripetal force. Here, that centripetal force is provided by friction, and here also there is friction. Okay, and there will be, if you look at it from the rotating frame, it becomes easier to understand why you need to bend. Here there is no bending required. If you are in the rotating frame, you will realize that there should be a pseudo force Fp. Here also there should be a pseudo force Fp. Everybody understanding this? Why is the pseudo force there? Yes, Sisoji ready. That's the plan. In fact, most of the chapters will be done by in the next couple of days. Now, don't you see these two forces are creating like a torque? Do you see there is a torque which is created? Torque. Which kind of torque? Clockwise torque. One force here, one force there. Clockwise torque. If there is a clockwise torque, you should fall over there. You should fall over there. Like that, you will topple, right? It's a toppling torque. But you don't want to topple, obviously. So what happens in case of a car? There is a anti-clockwise torque which is created by a larger normal here and a smaller normal here. So this normal, which is larger and this is smaller, it creates a balancing torque here, and that's how the car remains stable. That's how the car remains stable. But in case of this guy, who is that torque which will balance the pseudo force and friction torque? That is by mg and normal. So the normal and mg, you can see they create an anti-clockwise torque to balance it, and that's why you need to bend over a little bit so that you can counter the clockwise torque generated by the outward force. I hope that is clear. Understood? Oh? Clear? Oh? Amazing? Oh? Fair enough. Let's move on to the next part. Let's talk all about pendulums. So one of the most simplest of them is your conical pendulum. Oops. Okay, so this is basically your conical pendulum, and what and all you have some velocity, omega, whatever you want to call it, and there is some radius, there is some length, obviously there will be some tension, all of that, tension will be there, mg will be there, and so on and so forth. This is how it looks like. So certain things which you should know. By the way, let me also complete this. This is theta. So few equations which you should know is that in this situation it's always the tensions cos theta which balances mg. Tensions cos theta balances mg, and tensions sin theta is going to give you m into AC. So if I ask you what is the centripetal force in this situation, answer it in the chat box. What is the centripetal force in this situation? The answer will be the force which is towards the center, that is only this T sin theta. This is your centripetal force. And when you solve all of this, you get the tension is m omega square into length. This is one equation which you get. And you also get the equation for cos theta. Cos theta, so basically I think it comes out something like omega or v square by gl. You can just figure it out from here, divide it, and you can solve these equations and you can get it. Okay? So that's something which you can figure out if you draw the free body diagram and solve the equations. But mainly you will need the problems, you will need this equation for solving the questions, and you should know which one is the centripetal force, which one is not. See, I'll be solving problems towards the end, not now. Okay? So Shravani, Gite, there is a series called as Nurture series. Just go to the playlist tab, you will see sections. 11th standard section you go to, in that you will see chemistry, physics, maths. Just go to the physics part, click on it, you will see right from the beginning till the end all chapters, including the bridge course is also there right now. Okay. Now once you understand this conical pendulum part, there is also simple pendulum, and then you can have vertical circular motion and all of that. We'll talk about it. First of all, talking about simple pendulum, like this is my vertical line. Okay, these are my extreme positions. This is called as the mean position. I can draw an arbitrary position. Oh my god. Okay, I can draw an arbitrary position. This I will call it theta, and this or that I'm just going to call it theta naught. Theta naught, that's the max angle. Theta is some random angle in between the two extreme ends because it's going to go back and forth, back and forth. The mass is m, tension will be T. So guys, tell me one thing. If I draw the free body diagram over here, this is tension and this is mg. Okay, mg will have two components, obviously. Mg will have two components like this, correct? Okay, now tell me, if this is theta naught, shouldn't this angle also be theta naught? Shouldn't this angle also be theta naught? So at this point, isn't the velocity zero? Isn't the velocity also zero? Fair enough, guys? Okay. Now, at the same position, instead of splitting mg into two components like mg cos theta naught and mg sine theta naught. What if I split tension? What if I split tension? So I will get two components of tension. Remember, the tension was like this. If this was theta naught, so will this be theta naught. And then I will get this component as t cos theta naught, and this will be t sine theta naught, and this will be mg. Fair enough. Now, if you split tension, then you will say t cos theta naught will be mg. Correct? T cos theta naught will be mg. But if you look over here, then you will say, oh, tension and mg cos theta are balancing. So tension is equal to mg cos theta naught. My question to you is this correct or is this correct? Because both are misleading or contradicting. Think about it, because this is very important. If you don't understand, you will not be able to figure out many of the things in simple pendulum. So if I split tension, then I get mg is being balanced by t cos. If I split mg, I get mg cos is t. Oh my god, this is like Newton's laws. Every time it happens, I don't know which one to split. Normal should be split or mg should be split, and I always get confused. If you have that kind of a doubt, then this problem is going to solve that doubt. Which force you have to split? Thank you, Shreyas. I hope, Shravani Gite, you have understood which series you have to watch. Sri Sam, hold on. We are going to come to problems now in a bit. Come on, guys. What should be the answer? Well, the answer comes from acceleration. Tension should be split. Okay. Well, that is wrong. I'll tell you why. Because if you go over here, okay, if you go over here, velocity is 0. So centripetal acceleration is 0. Centripetal is v square by r. V square by r. So gone. But tangential, yeah, the speed will increase. So tangential is there. Now if you notice, tension and mg cos are perpendicular to the acceleration. But if you notice here, oh my god, one second. If you notice here, acceleration is there. In fact, acceleration will also have some components. One component here and one component here. So technically speaking, t cos theta will not be equal to mg. Will not be equal to mg because mg and t cos will have some unbalance because there is a component. This is theta naught. This is also theta naught. So actually speaking, mg minus t cos theta naught will be mass into tangential accelerations. Oh my god. Tangential okay, wait a minute. Let me just use some other part. Here you will see actually mg minus t cos theta naught will be equal to tangential mass into tangential accelerations cos. No, not cos, sine theta naught. Because you will see acceleration has a component, acceleration is down, so this force minus that force is mass into acceleration. That's why this is not correct. Got it? But here there is no such problem because there is no acceleration. You can see centripetal is actually 0. So hence you will see that t will be equal to mg cos theta. So there is nothing wrong in this. But yes, this is not correct. Got it, guys? So never make this mistake. Then this is all a part of vertical circular motion, obviously. When you come at the bottommost point, so when you are here, then what happens is that I don't know which color to use now, maybe yellow. Okay, so here you have tension, here you have mg. Now guys, quickly tell me, is tension equal to mg? Yes or no? Yes, this was always very confusing, and I know many teachers don't teach it, but I usually teach these things because these are small things which are very important, and that's what will decide whether you are getting those marks or not. So is tension equal to mg? No, it is not equal to mg, because at this part you will see that there is some kind of centripetal acceleration because there is some velocity, but tangential acceleration will be 0. Why is the tangential acceleration 0? Because there is nothing in the tangential direction, nothing to accelerate or decelerate it. So that is 0 at the mean position. Centripetal is there. So over here, since it is accelerating up, this must be more than this. So T minus mg will be equal to mv square by r, or length, whatever you want to call. Just Newton's laws. So this net force is your centripetal force. T minus mg is centripetal, not tension nor mg. So a lot of people again make a mistake there, which is centripetal. The total force is the centripetal force. Remember, centripetal force is a name given to a force. Got it? Fair enough? So glad of it. Next point, which you should know, especially the topmost point, these kind of questions are also common. Normal is lost, contact, or the string becomes slack. These kind of questions do come. So especially if this pendulum goes on the top, so at the top most position, what you need to do, okay, let me just put it over here. So let's say this is the path, this is your bob, it could be also a block which is going on a curved track, it works for that as well. This is your string, this is the center, okay, this is your mass. I hope I have not drawn it too up, but it's okay. Now I've drawn it. All right. So usually what happens, there is tension. If it's a curved track, it will be normal. There will be mg. That's it. Don't show anything more. And there will be centripetal acceleration like this. There will be centripetal acceleration like this, whose value will be v square by the length, or v square by r, where this is your velocity. Now, if you write the equation, this is how it looks like. Just write normal Newton's law. F is mass into acceleration. F is tension plus mg will be equal to mass into acceleration, which is m into v square by L. So this is T plus mg. But if the string has to just become slack, if I tell you the string has to just become slack, so that means tension will be 0 if it just has to become slack. Hence mg will be equal to mv square by r. Hence what will happen? Mg will be equal to mv square by r. So then what will you get? You will get v is root gl. This is the velocity for which the string just becomes slack on the top. Vertical circular motion, many dynamics part I'm doing it now, but the those kind of problems, complete vertical circular motion, root 5 gl, root 4 gl, root 2 gl, those kind of things, that's a part of work per energy. I'll be doing it in the work per energy session. Okay, Rohan? Okay, is this clear, guys? So you should know how to solve these kind of questions. This is also valid for curved track, where a vehicle is going on that curved track, vertical track, and it's at the topmost point, it should not fall down. Fair enough. I think I have covered most of the concepts. If there are some minor concepts left, maybe you can go through my detailed classes or through the crash course. But these are the things which I feel which will help you revise through circular motion, Newton's laws, banking roads, pendulums, vertical motion, free body diagrams, the inner concepts of Newton's laws, and the different kinds of forces, spring force, etc. Keep this in mind. Jamesburg, it depends, bacha, like whether you are in 10th moving 11th, 11th moving 12th, 12th moving passing out batch. If you're a passing out batch, right now at this stage of life, you should be studying totally for 10 to 15 hours per day, because you don't have school or anything right now. So ideally 12 hours at least, 15 hours pushing yourself, because it's the last few weeks before your exams. But if you're in normal school going student and you're in 10th to 11th or 11th to 12th, then 6 to 8 hours total studies, and you can divide it 2 subjects per day, sometimes very rarely 3 subjects, but usually it should be 2 subjects per day. Thank you, Rajendra. Thank you, Rohan. Okay, I think I have covered many things. Yes. So I think it's a good time to solve questions now. Let's start with some questions. Coming up on your screen, some of them are PYQs, some of them are own problems. Okay, a body moves with some speed on a rough surface. If F is the dynamic friction plotted with time as shown, then which of the following is the correct graph? Come on, my warriors, figure this out. Just 1 second. Always Jay, thank you. B, I have school 12 hours a day. Ratnapus, I'm guessing you are just entered 12th. So yes, I was talking about 12 hours a day for passing out batch or droppers because they don't have school now. So if you are just entering 12th, Ratna, then 6 to 8 hours. Okay, so guys, the correct answer is not B. You guys made a mistake. That's why you should attend these classes. It is this one. Read the question. You got overconfident. You looked at this graph. It looked very familiar. Read the question carefully. Dynamic friction. That means kinetic friction. And kinetic friction is always constant. So if it is constant, it should be this. I was not talking about total friction as a graph of pulling force with the frictional force. No, this is versus time, and that too for friction. It's always going to be mu k into n. Be careful. Moving on, next question. Yes, Himanshu, you can definitely take the crash course for the last 20 days. Himanshu, and I'm also telling you, it will be also valid for your next attempt, because I'm pretty sure you will realize, oh, I should have done this. Oh, I should have focused on that topic. So you will use those assignments and mock tests for the second attempt also. Anyways, the validity is there till JEE Advanced. You can even use it for JEE Advanced. So go ahead with it. The link is there in the description box below. Okay, Himanshu Bacha? And even I am teaching over there. So other teachers are also there. You will enjoy it. I'm pretty sure. Okay, so let's see. What about the weight that this block should have so that this just slips, or so that it does not slip? So what is the maximum weight? So this should be actually the word maximum should be there. So what is the max weight that you can put so that this block doesn't move? So let's start with the free body diagram, of course. So if this block shouldn't move, then it just means that the tension force should be balancing the frictional force, which is mu into n. This is your normal. The normal will be equal to the weight, and weight will be 60 Newton for this block. So from here, normal should be equal to weight, which is equal to 60 Newton, and the tension force should be balancing the frictional force, the maximum value, which is nothing but mu into n. Mu value is 0.5. Normal value is, oh, I found it out here, 60. So this will just become 30 Newton. So that's your T1 value. I'll keep this aside. Now, whenever you see a string joint problem, always remember you are going to draw the free body diagram of the joint. Always remember, whenever you have 3-4 strings connected, you always draw the free body diagram of the joint, because the joint is at rest and the mass of the joint is 0. Mass of the joint is 0. I hope this is clear. Now, what you should do, just show the forces acting on it. Like this one force is obviously going to be T1 because it's the same string, of course. This one is going to be T2, but I can split this tension into two parts. Oh, this is 45. This is 45. So this will be T2. This is T2 by root 2, because T2 cos 45 sin 45 is the same thing. So this is T2 by root 2. This is also T2 by root 2 by taking components of this 45, cos 45 sin 45. Okay, and last thing is the weight. This weight of this block is going to pull me down. All right, now you can see in the x direction, what do you see? The tension is being balanced by T2 by root 2. Tension 1 is being balanced by T2 by root 2. Oh, but wait a minute, T1 is 30. So T2, therefore T2 by root 2 is 30. In y direction, weight is balanced by T2 by root 2. So T2 by root 2 is weight. Oh, but T2 by root 2 is also 30. Hence, W is equal to 30 Newton. That should be the answer. 30 Newton. How many of you said it? Draw and draw. Correct, bacha. Oh, you're passing out batch. Then how do you have school, Ratna? I'm confused. Aarti, when did you send me a message, bacha? I'm not sure. I've got many messages. I don't know. It keeps getting lost. I need to check on that. If you put up a message now, maybe it will come on the top. Maybe I'll try and reply it. Hi, Vignesh V. Okay. So just a question of choice of the system, resolving the forces, drawing FBD, understanding the meaning that if it has to slip, it will be limiting friction. So substituting the values till we get the final answer. Moving on to the next one. Okay. Now in this question, the acceleration of the 2 kg block is, this is a very good question. First of all, will 2 kg and 4 kg move separately? Like the bottom one moves faster, or will they move together? Answer that first. Without that, you cannot solve the question. Look at the values of the coefficient, you will get the answer. You will understand whether they are moving together or whether they are moving separately. Are they moving separately or they will move together? If you notice, the block below has more coefficient. The block on the top has less coefficient. So what does that mean? The bottom one, more friction, so it will not move fast. The top one will try to move fast because of less friction. So because of which, the top one will push the bottom block. It will push the bottom block and they will stick to each other and move. If this was 0.2, that was 0.3. This is 0.2, that is 0.3. They will separately move with different accelerations. Because the bottom one has less friction, it will just lose contact with the top one. The top one will move slowly. Is that understood? Give me a thumbs up. Now let's draw. See, choice of system is very important. So let's draw the free body diagram by taking the complete thing as a system. So I'm going to take this whole thing as my system because it makes sense. Reason, I don't want to show the normal between them because that's an internal force and it hardly matters. They are moving together. So let's show the acceleration first and let's also show the forces acting on it. Well, there is going to be a normal here and a normal here. Okay, I'm just going to call it N4 and normal on 2 kg. Well, there is going to be weight which will be 4g sine 30 and also 2g sine 30. Both will be acting down. 4g sine 30, 2g sine 30. Yes, there is going to be 4g cos over here. So this will be 4g cos 30. This will be 2g cos 30. Not just that, apart from this, there is going to be frictional force F4 and F2. Be careful, each of them will be different because of different coefficients of friction. Okay, now let's make the equation. So net force along the incline is basically mass into acceleration. This is the total mass. So along the incline, this force minus this force and that frictional force is the total mass into the acceleration. That's all. So it will be 4g sine 30 plus 2g sine 30 minus F2 minus F4 is total mass, which is 4 plus 2 into the acceleration. That's it. So I think g will become 10. So I can put sine 30 as 2. So it will just become nothing but 4g plus 2g, which is nothing but 6g sine 30 is nothing but half, minus F2, which is mu mu for 2 kg is 0.2. So 0.2 into normal minus 0.3, my bad, 0.3 into the normal on 4 kg is equal to 6 into A. Fair enough. So this 2 cancels with this 6, it will become 3. So 3g is nothing but 30, correct? And this will become 0.2 into normal. Normal on 2 will be 2g cos 30. So it will be 2 into 10 into cos 30 minus 0.3 into 4 into 10 into cos 30 is equal to 6a. Now just solve this and you will get the answer, guys. I mean, like, come on. 30 minus 0.2 into 10 is 2. 2 2s are 4. 4 into cos 30, 4 root 3 by 2, that's 2 root 3. And this 0.3 into 10, 3. 3 4s are 12. 12 root 3 by 2. 12 root 3 by 2 is 6 root 3. So minus 6 root 3 is equal to 6a. So this will become 30 minus 8 root 3. 30 minus 8 root 3. So 30 minus 8 root 3 is equal to 6a. Divided by 3, this divided by 2, this will be 4 and this will be 15. So a will be 15 minus 4 root 3 divided by 3. So that's it. Solve this, you should get the answer. Just check this out. I think it should be one of these options. Just check it. Which value does it come out to be approximately? See if it is approximately 2.66. Approximately. George says it is option B. Yes, it is. I guess, Aarti, now you understood how to solve the question. So it was all about choice of system and noticing that the frictions are different and resolution of the forces. That's all. Yeah. Cool. Shall we move ahead to the next one? Okay. How about this one? There is a force pressing a block against a wall and there is coefficient between them. What is the weight of the block if it is just maintained at rest? Okay. So if you are pressing it against the wall, there will be a normal reaction by the wall. There will be a weight of the block. And I think the question is itself, what is the weight? And because the block would like to slide down, there will be a friction which is opposing up. So there will be a friction which is opposing up. It's just a matter of writing very simple equations. In x direction, if you notice, because this entire thing is going to be at rest, so all the forces should be basically balanced in nature. Balanced in nature. Upward force is downward force, leftward force is rightward force. So 10 should be equal to the normal force. This is one thing. In the y direction, you will see weight will be equal to the friction and friction will be mu into n. Mu value is 0.2. The normal force is nothing but 10. So it should be just nothing but 2 Newton. That is the answer. Then done are done. Oh, this was asked in your shift in 2021, is it? Oh, I don't remember, but I think fairly easy question. You should have got it. Fairly easy. Okay. All right, Sudan, you can just almost take it as 2.66 roughly, give or take. Moving on to the next question. A car of this much kg moving on a circular path of radius this much with a speed of this much. When the driver applies the brake and the car continues to move in the circular path, what is the maximum deceleration possible if the tires are limited to the horizontal friction of 7 kilonewton? This is a brilliant question because you will see why many students will make a mistake in this. So let's look at it from the top view. So this car is there. It is going in a curved path like this. Okay, this is a top view, mind it. And the velocity is like this. Brakes are applied. It's clearly mentioned when the driver applies the brakes. So velocity is that way. The brakes meaning acceleration will be behind, but this would be the tangential acceleration, which exactly we want to find. So the question is, what is the maximum deceleration possible? At what rate are you decelerating? Okay, that's what we are going to try to find. Now, what we are going to do is, when you are going in a circular path, there will be also centripetal acceleration. There will be centripetal acceleration. Everybody agrees with this? Okay. Now, because of these two accelerations, there will be a net acceleration. There will be a net acceleration. Correct? Now, because of the net acceleration being at certain direction, this is the direction in which the net force should be. This is the direction in which the net force should be, and the plane of your screen, is the horizontal plane. Keep in mind, normal will come out of the plane, mg will go inside the plane. They are not in the plane of the board. There is only one force which can act in the plane of the board, and that should be friction. That should be friction. See if this makes sense. See if this makes sense. So this force has to be none other than friction, because I know normal force is coming outwards and mg is going inside the plane of the board. Everybody are clear about this? Now what will I say? I'll just say F is equal to mass into acceleration. But wait a minute, acceleration is root of AC square plus AT square. Okay, and centripetal acceleration is V square by R, this square plus AT square. Okay, fair enough. I think we need to just start substituting the values. Let's start doing that. Let's start doing that and see what do we get. Frictional force, the max value is 7 kilonewton. So 7 into 10 to the power 3. Mass is given to be 1400. This thing, V square by R, velocity is 8. So it will be 8 square divided by R. R is 4, the whole square. Okay, is that clear, guys? Is that clear? Okay, plus AT square. AT square will come over here. Fair enough. So let's see what and all things go off. This 0 goes off. This 110 remains because 10 to the power 2 will go off. Only 110 will remain. Okay, so this is just going to be 70 divided by 14. 70 divided by 14, that's going to be 5, is equal to 8 square. 8 square is 64. 64 divided by 4 is 16. I think this was not supposed to be that. I think this was supposed to be 16 meters, not 4 meters, because then I don't think it turns out to be a perfect square and all of that. My bad, guys. I think this radius was supposed to be 16 meters, I guess, not 4 meters, because then the answer will not match, I feel. Okay, so I vaguely remember it was something like that. So this should not be 4, this should be 16. 8 square is 64. 64 divided by 16 is 4. So this will just become 4 square plus AT square. Obviously, you know what is the answer for this. 5 square plus 5 square is 4 square plus 3 square. So obviously AT will be 3 meters per second square. It will be 3 meters per second square. Just check this out. Yeah, that's the answer. So I think this was not 4, this was 16. Yeah, that's how it is. Venkatar, try bacha. It's not the time to give up. Understand from these problems. Okay, so this was not 4, guys. This was 16. Cool. Shall we go ahead to the next part? Next question. Okay, what is the next question? A body of mass 3 kg hits a wall with a speed of 10 at an angle of 60 degrees and returns at the same angle. The impact time was 0.2. The force on the wall is how much? Let's try to solve this. Okay, so there is a wall. Okay, a ball hits it and rebounds. Okay, fair enough. At an angle of 60 degrees with the wall. So this is 60 degrees. And let's assume at the same angle it returns. So that means this is also 60 degrees. It's not the angle of incidence. Be careful. So it's not the angle of incidence. So this is 30 degrees. This is also 30 degrees. Okay. Now, as per the question, we have to find out the force. Will there be force in the x direction or in the y direction? You tell me that in the chat box. Think carefully. Symmetry is there. If you notice here, this ball has two kinds of momentum, one in x, one in y. When it rebounds, it has one in x and one in y. Think which momentum changed, which momentum did not change. Which momentum changed, which momentum did not change. If you notice it carefully, the x momentum has reversed. The y momentum remains the same. And force always changes the momentum. Force always changes the momentum. That means if x momentum has reversed, the only logical explanation for that is the force should have acted in the x direction only. That's it. And if you notice, what is the x momentum here and what is the x momentum here? This is final, this was initial. Initial momentum will be, well, this is 30, this is also 30. It will be mv cos 30, correct? Here also it will be nothing but mv, because this is 30 degrees, guys. Okay, mv cos 30, but the direction is opposite. Mind it, direction is opposite. So if this is positive, the final momentum should be minus mv cos 30. So if I had to write it, the change in momentum, which is final minus initial momentum, it will be minus mv cos 30 minus mv cos 30. So keep this in mind. These are the momentum values. This minus is from here. So it will just become minus 2 mv cos 30. But I'm only interested in the magnitude of the force. So magnitude wise, it is 2 mv cos 30. Now why did I find this out? Because I know if I divide this with time, I get the force value. And that's what the question is. This is the force which we have to find. So the force will be 2 into mass, which is 3, into velocity, which is 10, cos 30, which is root 3 divided by 2. The whole thing divided by the time. Time was 0.2 right over here. So 0.2 goes with 2 10 times. And just check this out. Yep, 3 root, oh, okay, fair enough. So 10 tens are 100, 100 by, oh, I can just do this. This is 5. So 50, 150. So this is 150 root 3. Just check this out. 150 root 3 Newton. That should be the answer. See if I have it. Okay, yes, it is there. 150 root 3 Newton is right over here. Yes, Joe and Roy. Yes, Yogesh. Yes, IIT aspirant. Perfect. Beautiful question. Understanding that only x momentum reverses, y momentum does not change, hence the force will be only in the direction of change in momentum. Number one, not making a mistake with the signs. A lot of people will say mv cos theta minus mv cos theta is 0. No, directions are opposite. So be careful with the signs. So momentum changes twice. So it will basically, be 2 times mv cos theta, not 0. Okay, and rest is force is change in momentum by time. Moving on to the next question, guys. Let's have a look at it. There's a block which is pushed momentarily and with some speed. If mu is the coefficient of friction, then the block will come to rest after some time. So we want to find out what is the value after which it comes to rest. So I think it's a question on kinematics, because if it has some velocity, its speed reduces and it stops, that means some deceleration would have caused that stopping, and we can find how much is the deceleration by FBD. There will be a normal force, there will be mg force, and there will be frictional force, which is kinetic, which will cause the deceleration. By simple Newton's laws, Fk is mass into acceleration, Fk is mu into n, this is mass into acceleration, n is m into g, this is mass into acceleration, acceleration is mu into g. Okay, we got acceleration. We want to find the time after which it stops. Obviously use kinematic equation. Final velocity is initial velocity plus acceleration into time. Final velocity 0. Initial velocity v. Acceleration is negative, it is retardation, so technically this is minus. Okay, this minus stands for deceleration. Deceleration. So that's why minus, which is mu into g into time. Rearrange, you will get mu gt is equal to v. So time is v by mu g. That's the answer. Do I have it somewhere? Yeah, v by mu g. It's right over there. Option D. Option D it is. Very good. 151 is a good score. I got an MTA app. Bhuwana 150 might not bring you to NITs, honestly speaking. Maybe some lower NITs, lower branch, but you need to push yourself to 180 plus, at least 180 plus. Okay, please keep that in mind. Kalpana, this was a block which was pushed. So if you push a block and leave, it will slowly decelerate and stop. So during this motion, it is decelerating. So I had to find the deceleration to find the time. Draw FVD, normal, mg, friction. F is ma. Friction, kinetic, because it is moving. Kinetic friction is mu n is mg, normal is mg. So I found out acceleration is mu g, or deceleration is mu g, as the magnitude of it. Use kinematic equation. Final is initial plus acceleration into time. It stops finally. Initial velocity was v. Acceleration, magnitude wise, I found it mu g, but put a minus sign because it is decelerating. Rearrange, you get v by mu g. That's all. Cool, everyone? Let's move on. The train is moving with certain speed of certain, this speed on a curved path of thus radius. Distance between the rails is 1.5, the height of the outer rail over the inner rail. So these kind of questions are based on basically banking, and in these kind of questions you have to basically understand if this is the outer rail and this is the inner rail, there is an angle between the inner rail and the outer rail. There is a height difference. This is a distance between the two rails, so that the train moves effectively. The train moves effectively. So the train is over this. The train is over this, and the velocity is into the plane of the board. It's going like this on a curved track. So in such situations, whenever you have to find the height difference between the tracks, etc., think about the formula for optimum velocity on banked road. On a banked road, just use that formula, nothing else. So let's see what do we get. Optimum formula speed is root of rg tan theta, squaring both sides, so v naught square is rg tan theta. You can see tan theta is h by d, so it will be h by d. So v naught is, we need to figure this out, 36 kilometers per hour. So 36 into 5 by 18, which is going to make it 10 meters per second. So it will be 10 square. Radius 200, g 10, height I do not know. Distance between the rails 1.5, so just put 1.5 here. Okay, 100 and 200 cancel, so it will become 1 is equal to 2 into 10 into h. 1.5 is 3 by 2, I guess. Okay, fair enough. Moving this around, so h will be equal to 3 goes on the top, 4 comes below, and 10 also comes below. So this will be 3/4 is 0.75 by 10. So this will be 0.075 meters. So that's very small, 7.5 centimeters. It's there, right over there. There you go. Bhuvana, yeah, the angle, if it is there, then the formula is just mr square by 2. No matter what the angle is, it remains as mr square by 2 only. I've explained that in my moment of inertia class. It's there in the playlist. Just check it out. Just open the long-term series, nurture series. It's there in the moment of inertia session. Okay, you can just check it out. Okay, next question. A string passes over a frictionless pulley, has this much mass attached to one of its end. To the other side, 10 kg mass is attached. What is the tension in the thread? Now, usually in these kind of questions, many students make a mistake. So basically, there is a pulley, and on this side, you have one mass, this side you have another mass. One side is 6. One side is 6. Other side is 10. Many people think the tension in the string will be the difference of the masses. No. It will be average of the masses. No. Addition of the masses. No. You have to do it by proper FBD, like 10g minus t is equal to mass into acceleration, tension minus 6g is equal to mass into acceleration. Solving these equations, you get t is equal to 2 times m1 m2 divided by m1 plus m2 into g. So now substitute the values. So you get this via free body diagrams, solving Newton's law equation simultaneously. Mass 1 is 10, mass 2 is 6, g is 10, divided by 10 plus 6, of course. So, oh my god, let's see. 2 into 10 into 6 into 10 divided by 10 plus 6 is 16. So let's try to see what and all happens. So 2 goes with 16 8 times, 8 becomes 4, so this becomes 5, this becomes 2, so this becomes 3, this goes off, becomes 1, this becomes 5. So it will become 5 into 3 into 5, 5 5 is 25, 25 3 is 75. 75 Newton is the answer. Option C it is. It is not 50, it is not 80, it is not 160, it is not 40. Hello Nandini, welcome bacha. Got it? Clear? Cool. So this was based on your FBD forces, and this goes down, this goes up, something like that. Yep. Cool. Let's move on. Okay, a mass is performing uniform vertical circular motion, my bad. See the figure. If the velocity of the particle is slowly increased, average velocity, then where do you think maximum braking possibility? Where do you think it's very likely it will break? A, topmost point, B, bottommost point, D, leftmost point, C, rightmost point. Hello Vikash Babu. Come on guys, you should be able to do this. Very easy peasy lemon squeezy. What is the answer? Obviously, the chances of it becoming slack, loose, is at the highest point. It will become loose. Question is braking. Braking means tension should be maximum. And tension is maximum at the lowest point because the tension will be balancing mg and there is a centripetal acceleration here. So T max minus mg is mac. So therefore T max is mg plus mac. That mg goes on the other side. Because of this plus, it becomes maximum. At the top, it becomes minus. So hence, it is maximum at the bottommost point, which is point B. B option. That's not A. At the topmost point, keep this in mind, it is in fact minimum tension. That's where chances of it becoming slack, chance of becoming slack is there at the topmost point. Got it? There's a difference. Cool. Alrighty. So guys, I have kept this question for homework. So this is your homework question. What are you going to do? Yeah, you're going to put up the answer in the comment section. So drop the answer in the comment. No matter when you're watching it, I'll be seeing your comments, of course. So I'm not put up the solution. I have kept it in the PDF, which you'll be getting in the Telegram channel. There is also a daily practice quiz for all of you in the description box. Also, a link for joining the NEET and JEE crash course is also there in the description box. Although these are recorded classes, trust me, they are interactive in nature. You can still give these quizzes and hotspots and all those things. And it's just for 2,700 bucks. So I'll show you where you can find all these links right away, right now. So this is where you're watching the video, my video. All right, so that's live class. Okay, that's me. Now go down, you can see right over here. You will see there is a V-quiz link. V-quiz. This is your daily practice problems. Some 5 to 7 problems will be there just after the class. start by clicking on joining the quiz and just say enter the quiz and give it in a timed manner. That's all. Okay, so I'll not play it for you. You have to do it on your own. Next thing, you can see the Telegram channel link is right over here. Okay, next thing, whether you want to join the JEE batch or NEET batch, accordingly you will have these links. Crash course link has not yet come, but don't worry. Even if you click on anything and you want to change the course, just click on this change, and you are a class, let's say 12th student, and okay, I don't know, how do I get it? I think it should have been there, guys. Okay, I have to put that link. The crash course link is not there, but I'll put it up later on, definitely. Okay, I'll definitely put it up. So you can join the courses, and tomorrow onwards the course prices are going to increase for everything, be it for 2023, be it for 2024. Let me assure you on that. Okay, cool. So thank you very much, guys. I hope you guys had a great time out here, and I'm so happy that you made it till the end. And make sure you solve the week quiz. Also go through the PDF. Also go through whatever I have taught you today. Bye bye. Thank you, Crazy Vix. Thank you, Yogesh, Aarti, Joyce. Thank you everyone for being here. Take care. Have a great time. See you again in the days to come. Hasta la vista.